let's see the next question. A body of mass m is equals to, that is your 10 to the power minus 2 kg. So this is nothing but the mass is given, moving in a medium, experience a frictional force. So F is equals to minus kv square over here. Its initial energy speed is v naught. So v naught is nothing but 10 meter per second over here, and the final velocity vf is nothing but, again, that is a half. So that is your 1 by 8. So 1 by 8 mv naught square over here. So I know that. So generally, so this is your half mv naught square. Yeah, so this is the initial one, and again I know that. So it is nothing but the final one. So they can say that. So for this one, so let's say, so this is nothing but the final they have given over here. So the final one they just mentioned that over here. So for this particular case, yes, so for this particular case, so they are saying that obviously it is nothing but your 1 by 8. Yeah, so this is nothing but your 1 by 8. Yeah, so that is your mv naught square over here. So generally I know that. So this is, let's say, I will say this is the final one. So this is the final one. So the final mvf square over here. So you can say that. So this is a vf square. So this is a 1 by 4, and again I can say further. So this is a v naught square. So vf is equals to, you can say v naught by 2. So v naught by 2 over here. So the given equation is f is equals to minus k v square. Then we can say that obviously f is equals to mass into acceleration. Again, that is a minus k v square. So m into dv by dt is equals to minus k v square over here. So you have to just separate those variables. So that is a m dv upon v square. Yeah, and again you can say that. So that is a minus k into dt over here. So just evaluate this one. So that is a v to the power minus 2. Again you can say that. So that is your integration. You have to take it on both the sides over here. So you can say that. So that is a minus, again, v to the power minus 2 into dv, and that is a minus k into t for this particular case over here. So this is again further. Yeah, so just take that. Yeah, so just you can just write down the value for the same over here. So this one you can write it down, v to the power minus 2 over here. Yeah, so this is your minus 2, and again you can say that. So that is a v to the power minus 1, and again that is your minus kt. So let's say, for example, then 2m upon v and kt. So 2m upon v is equals to kt. Now the limits for your v is nothing but, so the final, yeah, so you can say that the initial is 10, the final is your 5. So that is a 2m. So this is 1 by 5 minus 1 by 10 over here. So this is k, and what is that t they have just given? It is a 10 seconds. So it is 10 seconds. And again, what is the value of your m? So m is nothing but, that has been mentioned over here. So that is 10 to the power minus 2. So 2 into 10 to the power minus 2 over here. So for this case, yes, so even for this particular case, so this is how we can write it down, the things over here. Fine. So let's say this is, again you can write it down. So 2 minus 1, 1. Again you can say that. So this is your k into, that is 10 over here. So you can say further for this particular case. So this is 2 into 10 to the power, again let's say that is a minus 3. Yeah, and again 10 is equals to k. So that k is equals to, you can say that obviously. So that is the value that we will get over here. So see, so this is how we had just done the integration for the same over here. So separating the variables. Yeah, and again further we had just took the result for the same over here. So finally we will get, yeah, so this is 2 into 10 to the power minus 4. So this is 2 into 10 to the power minus 4 over here. So that is the value of your k for this particular case.